What if everything we believe about human history is incomplete? Not slightly wrong, but fundamentally missing an entire chapter. Not a lost city, not a forgotten empire, but an intelligent civilization that existed on Earth long before us and vanished so completely that almost no trace remains. It sounds impossible at first, but when you look closely at the science, that certainty starts to crack. Imagine this for a moment. If dinosaurs had not gone extinct 66 million years ago, they would have had more time than humanity has ever had to evolve intelligence, develop tools, and build something resembling civilization. We don't know if they would have, but more importantly, we cannot prove that they didn't. And if they had reached that level, almost nothing would remain today to confirm it. Time is ruthless. It erases nearly everything. Now consider an even stranger possibility, one that already exists today. Octopuses and their relatives, known as cephalopods, have been on Earth for over 500 million years. They possess the most complex brains among invertebrates. They solve problems, use tools, recognize individual humans, and even display behaviors that look like curiosity and play. But there's a catch. Their bodies are soft. They leave behind almost no fossils. If an intelligent cephalopod civilization had existed hundreds of millions of years ago, we would have no reliable way of knowing. No ruins, no skeletons, no clear evidence, just silence. And that silence is deeply unsettling, because it reveals a limitation in how we search for intelligence. We look for technology, metal, machinery, structures, but what if intelligence doesn't always follow that path? What if a civilization developed entirely differently? A marine civilization, for example, based on biological manipulation instead of metallurgy, might leave behind nothing we would recognize as artificial. Then there's the possibility much closer to us, hidden within our own evolutionary tree. Over the last century, scientists have discovered that human evolution is far more complex than we once believed. Species like Homo erectus, Neanderthals, Denisovans, and others lived alongside or before us. Some had large brains, some used tools, some may have had language and culture. But here's the critical detail. We have fossil evidence for less than 1% of all species that have ever existed. Entire branches of evolution could have risen and disappeared without leaving a trace. So the question becomes unavoidable. Could one of these unknown hominin species have developed a form of civilization long before recorded history and then collapsed? The standard answer is no, because we would expect to find evidence, tools, structures, environmental impact. But that assumption depends on something we rarely question: that evidence survives, because it often doesn't. If a civilization existed millions of years ago and lasted only 10,000 years, a blink in geological time, most of its traces would be gone. Metal would corrode. Buildings would collapse under earthquakes, erosion, and vegetation. Landscapes would reshape. Even environmental changes would be overwritten by future shifts. The absence of evidence doesn't necessarily mean nothing was there. It may simply mean time has done its job too well. And then comes the most unsettling possibility of all. What if something existed here before us and it didn't originate on Earth? Our planet has been struck by asteroids and comets throughout its history. Some impacts were catastrophic, like the one that wiped out the dinosaurs. But these impacts don't just destroy, they also deliver material from elsewhere in the solar system. Scientists have already found rocks on Earth that originated from Mars. That means, in theory, life or even evidence of intelligent activity could travel between planets. Mars itself is especially intriguing. Today, it is a frozen desert, but billions of years ago, it was warm, wet, and potentially habitable. If life developed there, if intelligence emerged and then disappeared, it's possible that fragments of that history reached Earth, buried deep within ancient rock layers, waiting to be discovered. This idea may sound extreme, but it leads to a disturbing implication. Intelligence might not be rare. Instead, civilizations might rise and then routinely destroy themselves or collapse, leaving behind almost nothing. And if that's true, then we are not looking at an empty universe. We are looking at a graveyard. What makes this even more serious is that scientists are no longer treating this as pure speculation. The idea has evolved into something called the Silurian hypothesis, a real scientific effort to determine whether an industrial civilization could have existed millions of years ago without leaving obvious traces. Researchers are now studying ancient rock layers with unprecedented precision, searching for unusual chemical signatures, strange isotope patterns, and unexplained anomalies that might hint at something artificial. Because if even a small fraction of this is possible, then the biggest question is no longer, are we alone? It becomes something far more unsettling. What happened to those who came before? And more importantly, could it happen to us too? To understand why this question is being taken seriously, we need to move from speculation into something much more uncomfortable: actual evidence. Not proof, not certainty, but patterns in Earth's history that don't fully fit the explanations we've built. Because when scientists began looking closely, they didn't just find gaps, they found anomalies. One of the most studied examples is something called the Paleocene-Eocene thermal maximum, often shortened to PETM. This event took place around 56 million years ago, and it represents one of the most dramatic climate shifts in Earth's history. In what is, geologically speaking, an incredibly short period, possibly just a few thousand years, massive amounts of carbon were released into the atmosphere. Global temperatures rose between 5 and 8 degrees Celsius. Oceans became more acidic. Oxygen levels dropped. Entire ecosystems collapsed. At first glance, this sounds like a natural disaster, and the standard explanation follows that path. Scientists believe volcanic activity may have triggered the warming, which then destabilized methane deposits on the ocean floor, releasing even more carbon and pushing the planet into a runaway greenhouse state. It's a plausible chain reaction. But there's a problem. The speed of the carbon release is difficult to explain using only natural processes. And more importantly, the chemical signature of that carbon, the ratio of isotopes, looks strikingly familiar. It closely resembles what we would expect from the burning of organic material, like fossil fuels. In other words, the same kind of signature our own industrial activity is leaving behind today. No one is claiming that an ancient civilization caused the PETM, but the data forces an uncomfortable admission. The signal is ambiguous. It matches natural explanations, but it also overlaps with what industrial activity would produce. And that uncertainty opens a door that many scientists once assumed was permanently closed. Now consider another event far more devastating. The Permian-Triassic extinction event, which occurred around 252 million years ago, is the most catastrophic extinction in Earth's history. Over 90% of marine species and about 70% of land species vanished. Life came closer to total annihilation than at any other known time. The leading explanation again points to natural causes, massive volcanic eruptions in what we now call the Siberian traps. These eruptions released enormous quantities of carbon dioxide, methane, and toxic gases, destabilizing the climate and poisoning the oceans. The timeline matches. The scale fits. It's a strong explanation. But even here, things aren't perfectly clear. The extinction didn't happen all at once. It occurred in pulses, waves of death, separated by brief periods of partial recovery. This pattern is difficult to explain through volcanic activity alone. And then there's the recovery itself. It took nearly 10 million years for biodiversity to return to previous levels. That's unusually slow, even for an event of this magnitude. Something prolonged the damage. Something prevented the planet from healing at its usual pace. Scientists have proposed additional factors, asteroid impacts, feedback loops in the climate system, but no single explanation fully accounts for all the details. And while it would be irresponsible to jump to conclusions, it would be equally irresponsible to ignore the unanswered questions. Because when you step back, a pattern begins to emerge. Multiple events in Earth's history involve rapid environmental change, massive carbon release, and widespread extinction, sometimes with signatures that resemble industrial processes, even if they can still be explained naturally. Now let's move to another event that complicates the picture even further, the Ordovician-Silurian extinction events. This occurred roughly 444 million years ago and wiped out about 85% of marine species. The standard explanation points to a sudden ice age. Temperatures dropped, glaciers formed, sea levels fell, and marine ecosystems were disrupted. Then, just as quickly, the ice retreated, causing another wave of environmental stress. But again, the timing is puzzling. The glaciation appears to have begun and ended more abruptly than many natural mechanisms can easily explain. Scientists have suggested various causes, changes in atmospheric carbon dioxide, shifts in ocean circulation, even cosmic events like gamma-ray bursts, but none of these explanations fully resolve the mystery. And this is where the conversation becomes truly uncomfortable. Because if we allow ourselves, even briefly, to consider alternative explanations, a different kind of possibility appears. What if the rapid drop in carbon dioxide wasn't entirely natural? What if it resembled something closer to deliberate climate intervention geoengineering on a planetary scale? And what if the extinction that followed wasn't the goal, but a side effect? This is not a claim. It is a question. But it is a question rooted in real gaps in our understanding. And then there's something even more subtle, yet just as important. The geological record occasionally contains unusual concentrations of elements, heavy metals, strange mineral formations, chemical deposits that don't fit neatly into known natural processes. Most of these can be explained, or at least modeled, within existing frameworks, but not all of them. Some remain unresolved. Individually, each anomaly can be dismissed as an outlier, but collectively, they begin to challenge a deeper assumption that Earth's history is fully understood, that every major event has a clear and complete explanation. Because the truth is, it doesn't. And the more closely scientists examine these layers of rock, the more they realize that Earth's past may not be as simple or as empty as we once believed. Which brings us to the next step in this investigation. If evidence can be erased, distorted, or hidden over millions of years, then how do you even begin to search for something that might no longer exist in any recognizable form? That question has led researchers into some of the most creative and unsettling approaches in modern science. And what they are looking for might already be hiding in plain sight. So how do you search for something that may have been erased almost completely by time? How do you prove or even seriously investigate the possibility of a civilization that left behind no cities, no machines, no obvious ruins? This is where the Silurian hypothesis shifts from a disturbing idea into a real scientific strategy. Because researchers are no longer just asking if it's possible, they're trying to figure out how we would know. The first approach is deceptively simple. Look deeper into the rocks we already have, not just visually, but chemically, atom by atom. Scientists are now analyzing ancient geological layers with far greater precision than ever before, searching for tiny irregularities, subtle shifts in isotope ratios, unusual chemical concentrations, patterns that don't quite match natural expectations. These are not dramatic discoveries you can see with the naked eye. They are microscopic fingerprints, buried in time. Think about what our own civilization is doing right now. We are pumping carbon into the atmosphere at a rate that is geologically sudden. We are creating synthetic compounds that have never existed before. We are spreading microplastics across the entire planet, from the deepest oceans to the highest mountains. We are leaving behind radioactive traces from nuclear activity that will persist for tens of thousands, even millions of years. Now imagine all of that stretched across deep time. Most of it would vanish. Cities would collapse, metals would corrode, plastics would break down, landscapes would shift. But not everything disappears equally. Some signals, especially chemical ones, can linger far longer than the physical structures that created them. And that's exactly what scientists are hunting for. Not buildings, but signatures. The second approach focuses on extinction events. We already know that our current trajectory is pushing Earth into what many scientists call the sixth mass extinction. Species are disappearing at rates far beyond natural background levels. If a previous civilization had a similar impact, even if it existed millions of years ago, there might be a recognizable pattern in the fossil record's sudden losses of biodiversity, especially among large and resource-dependent species, followed by strange or uneven recoveries. And when researchers re-examine past extinctions with this perspective, they notice something interesting. Some extinction events don't follow clean, simple narratives. They are messy. They happen in stages. They involve overlapping environmental stresses that don't fully align with a single cause. This doesn't prove anything, but it complicates the story in a way that invites deeper questioning. The third method is perhaps the most imaginative and also the most unsettling. Instead of only looking at Earth, scientists are considering places where evidence might survive better, places where geological activity doesn't constantly erase the past. And that brings us to the Moon. Unlike Earth, the Moon has no atmosphere, no weather, no plate tectonics. Its surface is ancient and largely unchanged for billions of years. If any civilization, human or otherwise, had ever developed spacefaring technology, even briefly, it's possible that traces of that activity could remain there. Fragments, debris, or anomalies that have simply sat undisturbed, waiting. This idea might sound extreme, but it follows a clear line of reasoning. If Earth destroys its own history, then you look for records in places that don't. The fourth approach is modeling, essentially turning the question back on ourselves. Scientists are running simulations to predict what traces our own civilization would leave behind over millions of years. Not in theory, but in measurable, testable ways. They ask, which signals would last? Which would disappear? What patterns would remain detectable after deep geological processing? These models are revealing something important. Even a technologically advanced civilization might leave behind only a thin, ambiguous layer in the geological record, a brief signal of disruption, easily confused with natural events, unless you know exactly what to look for. And that realization changes everything, because it means the absence of clear evidence is not strong evidence of absence. Now connect this to a much larger question, one that extends far beyond Earth itself. The Fermi paradox asks a simple but unsettling question. If the universe is so vast and so old, where is everyone? Why haven't we detected clear signs of other intelligent civilizations? One possible answer is that intelligent life is incredibly rare. But the Silurian perspective suggests something different and far more disturbing. Maybe intelligence isn't rare at all. Maybe civilizations arise frequently, and then disappeared just as quickly, leaving behind almost nothing. Not because they were insignificant, but because time erases them. This idea connects directly to another concept known as the Great Filter. It proposes that somewhere along the path from simple life to advanced civilization, there is a barrier, a stage, so difficult that almost nothing survives it. If that barrier lies in our past, then we are incredibly lucky. We made it through. But if it lies ahead of us, then it means something stops civilizations before they can spread, endure, or leave lasting marks. Something like environmental collapse, or technological self-destruction, or a combination of pressures we don't fully understand yet. And suddenly, the question changes again. It's no longer just about whether something came before us. It's about whether those civilizations faced the same challenges we are facing right now and failed. Because if that pattern is real, if civilizations tend to rise, transform their planet, and then collapse within a relatively short window, then what we are seeing in the geological record may not be random at all. It may be a cycle. A cycle so subtle, so easily erased, that each new civilization believes it is the first. And if that's true, then the most dangerous assumption we can make is that we are different. If this pattern is real, if civilizations can rise, reshape a planet, and then disappear so completely that only faint chemical traces remain, then the most unsettling part isn't the past, is what it says about us. Because for the first time, this idea stops being theoretical. It becomes personal. Think about how we see ourselves. For centuries, humans have believed we are unique, the first and only species on Earth to reach this level of intelligence, technology, and self-awareness. We see our civilization as the peak of a long evolutionary journey, the final result of billions of years of cosmic and biological development. But what if that story is incomplete? What if we are not the first, just the latest? That possibility forces a shift in perspective that is difficult to ignore. Because if something existed before us, something intelligent, capable, perhaps even advanced, then its disappearance is not just a mystery, it's a warning. And the deeper scientists go into this question, the more they realize that the real challenge isn't proving that a past civilization existed. The real challenge is understanding how easily one could vanish. Look at our own world today. We tend to think of our cities, our infrastructure, and our technology as permanent. Skyscrapers, highways, satellites orbiting the planet, it all feels solid, lasting, almost indestructible. But that confidence doesn't hold up when you stretch the timeline. Give it a few thousand years without maintenance and buildings collapse. Metals corrode, roads crack and disappear under soil and vegetation. Give it millions of years, and tectonic forces begin to recycle entire sections of the Earth's crust. Oceans swallow coastlines, mountains rise and erode. The surface of the planet is constantly being rewritten. In that context, our entire civilization becomes fragile, shockingly so. Not fragile in the sense that it could disappear overnight, but fragile in the sense that, given enough time, it could be erased almost completely. And this brings us to something that keeps many researchers quietly unsettled. Not a single discovery, not a dramatic piece of evidence, but a growing realization. When you combine what we know about geological processes with what we know about our own impact on the planet, it becomes entirely plausible that a civilization could rise, industrialize, alter the climate, trigger ecological disruption, and then collapse without leaving behind clear, undeniable proof. That idea doesn't rely on imagination. It follows directly from physics, chemistry, and geology. And once you accept that, a new kind of question emerges. Not where is the evidence, but are we interpreting the evidence correctly? Because we already know that Earth's history includes sudden climate shifts, unexplained chemical signals, and extinction patterns that are still debated. We've built natural explanations for most of them, and many of those explanations are strong. But not all of them are complete. There are gaps, uncertainties, edges where the data doesn't fully align. And it's in those edges that this hypothesis lives. Now, there's an important example that helps ground this idea in reality, not from deep geological time, but from human history itself. The Antikythera mechanism is one of the most striking reminders of how easily advanced knowledge can be lost. Discovered in a shipwreck and dating back over 2,000 years, it is essentially an ancient mechanical computer, capable of predicting astronomical positions and eclipses with remarkable precision. When it was first found, many experts refused to believe it was real. The technology seemed far too advanced for its time. There was nothing else like it in the historical record, and yet it existed. The knowledge required to build it had developed and then disappeared. For more than 1,000 years, humanity lost the ability to create something similar. That's within recorded history. Now extend that idea across millions of years. If a relatively small technological advancement can vanish so completely in just a few centuries, what could disappear over geological time? Entire systems of knowledge, entire civilizations, entire species capable of thinking, building, and understanding the universe gone without a trace? This is where the psychological impact of the hypothesis becomes unavoidable, because it challenges something deeply rooted in how we understand our place in the universe. We are used to thinking of ourselves as the beginning of something, the first intelligence to look back at the stars and ask questions about existence. But if we are not the first, then we are part of a sequence. And sequences imply repetition. It means what we are experiencing now, technological growth, environmental pressure, global interconnectedness, may not be unique. It may have happened before, under different conditions, with different species, leading to outcomes we can only guess at. For some, that idea feels unsettling, even threatening. It strips away the sense of uniqueness. It suggests that everything we achieve could, in principle, be temporary. But there is another way to interpret it. If others came before us, even if we never find direct evidence of them, then their disappearance carries information, not in what they left behind, but in what they didn't, in the silence, in the absence of lasting impact. And that absence raises a critical question. What did they do wrong? Or more importantly, what challenges did they face that they couldn't overcome? Because when we look at our own world, climate change, resource depletion, technological risks, we are facing problems that are not theoretical. They are immediate, they are measurable, and they are accelerating. If the Silurian hypothesis is even partially correct, then these challenges may not be new. They may be part of a pattern that repeats whenever intelligence reaches a certain level of power over its environment. And if that's the case, then the goal isn't just to survive, it's to break the pattern. Because the difference between a civilization that disappears and one that endures may come down to something very simple: the ability to recognize the risks early enough and respond differently. And that brings us to the next stage of this investigation. If there really are traces subtle, buried, almost invisible, then what exactly have scientists found so far that refuses to fit neatly into the story we've been telling? Because the closer we look, the harder it becomes to dismiss the possibility that something doesn't quite add up. Because when scientists say something doesn't add up, they're not talking about wild speculation or fringe ideas. They're talking about specific details, measurable, repeatable observations that resist clean explanations, not enough to prove anything extraordinary on their own, but enough to create a persistent sense that the full picture is still missing. Take, for example, certain chemical anomalies found in ancient rock layers. These are not dramatic discoveries that immediately rewrite textbooks. They're subtle, slight overconcentrations of heavy metals, unusual mineral formations, or chemical ratios that don't quite match what standard geological models predict. In most cases, researchers can propose natural explanations, and often those explanations are reasonable, but not always complete. What makes this important is not any single anomaly, it's the pattern. When similar irregularities appear across different time periods, in different environments, and under different conditions, it suggests that something more complex may be at play. Not necessarily artificial, but not fully understood either. Now combine that with what we already know about how our own civilization is altering the planet. We are redistributing elements on a global scale, mining, refining, and concentrating materials in ways that nature rarely does. We are introducing entirely new compounds into the environment. We are changing the atmosphere, the oceans, and the biosphere at speeds that stand out clearly in geological records. If a previous civilization had done something similar even briefly, it's possible that the only thing left behind would be a thin, strange layer of chemistry. No machines, no structures, just a signal, a disturbance. And that brings us to another category of evidence: structural anomalies. Not visible ruins or recognizable artifacts, but indirect signs that something may have altered the physical structure of the Earth. For example, large-scale mining operations, if they existed in the distant past, could leave behind unusual voids or density changes deep underground. Massive underground constructions could, in theory, create seismic signatures that don't quite match natural formations. So far, no such evidence has been definitively identified. But the key point is this: we are only beginning to look for it in a systematic way. For most of scientific history, no one was even asking this question seriously. Now, for the first time, researchers are developing tools and methods specifically designed to detect these kinds of subtle traces. And then there is perhaps the most overlooked factor of all: how easily we misinterpret what we find. Human history itself is full of examples where discoveries were initially dismissed because they didn't fit existing beliefs. The Antikythera mechanism is just one case, but it highlights a broader pattern. When something appears that challenges our assumptions about what should exist at a certain point in time, the first reaction is often skepticism, even rejection. Now imagine applying that mindset to discoveries buried millions of years in the past. If we encountered evidence that didn't align with our current understanding, something ambiguous, incomplete, or difficult to categorize, it's entirely possible we would interpret it as a natural anomaly, simply because that explanation feels safer, more familiar, easier to accept. This doesn't mean scientists are ignoring evidence. It means interpretation is shaped by expectation. And when the expectation is that no advanced civilization existed before humans, the threshold for considering alternative explanations becomes extremely high. But slowly, that threshold is changing, not because of belief, but because of necessity. As analytical techniques improve, as data becomes more precise, and as we learn more about how complex systems behave over deep time, the simple explanations are starting to feel insufficient. And that leads to a deeper, more philosophical shift in the conversation. Because at its core, this isn't just about geology or ancient history. It's about how we define intelligence and how we recognize it. We tend to think of intelligence in terms of technology, machines, structures, visible impact, but that may be a narrow definition. It's possible that intelligence could express itself in ways that don't leave behind the kinds of traces we're trained to detect. A civilization that relied on biological systems instead of industrial ones, a species that integrated with its environment instead of reshaping it, or even a form of intelligence that existed for a relatively short time and then vanished without expanding globally. All of these scenarios would be incredibly difficult to identify in the geological record. So the real challenge may not be finding evidence. It may be learning how to recognize it. And as scientists continue to explore these questions, they are beginning to accept something that once seemed unlikely, that the history of intelligence on Earth may be more complex than a single, uninterrupted line leading to us. But even if we never find definitive proof of a past civilization, the investigation itself is already changing how we see the present. Because when you look at the fragility of evidence, the scale of geological time, and the patterns of environmental disruption, one conclusion becomes harder to ignore. If something did come before us, it didn't last. And that brings everything back to the same critical point. This is not just a question about the past. It's a question about trajectory. Because right now, we are leaving behind our own layer in the geological record. A thin, rapidly forming signal of industrial activity, environmental change, and global impact. Future scientists, whether human or something else, might one day study that layer and try to understand what happened. They might see the sudden rise in carbon, the spread of synthetic materials, the sharp decline in biodiversity, and they will ask the same question we are asking now. What caused this? Was it natural? Or was it the signature of a civilization at the moment it reached its peak? And that final question, what caused this, may one day define how we are remembered or whether we are remembered at all. Because when you zoom out far enough, when you step back from the scale of human lifetimes and look at Earth as a system moving through millions of years, one truth becomes impossible to ignore. Civilizations, no matter how advanced they seem from within, may only occupy a brief, fragile window in time. Right now, we are inside that window. We are building, expanding, innovating at a pace no species has ever achieved before. Our technology connects the planet, reshapes ecosystems, and even begins to reach beyond Earth itself. From our perspective, this feels like progress, like a forward path that naturally continues. But the deeper question is whether progress guarantees survival or whether it introduces risks that grow just as fast as our capabilities. Because if the Silurian hypothesis has shown us anything, it's this. Intelligence alone is not enough. Reaching a high level of development does not mean a civilization will endure. In fact, it may be the moment when survival becomes most uncertain. Think about the pattern we've been tracing. Sudden climate shifts, rapid carbon release, mass extinctions, environmental instability. Whether these events were entirely natural or influenced by something more, they all point to a single reality. Planetary systems can change quickly, and when they do, the consequences are severe. Now look at our present. We are increasing atmospheric carbon at a rate that stands out even on a geological scale. We are altering ecosystems across the globe. We are introducing technologies whose long-term effects we are only beginning to understand. None of this guarantees collapse, but it places us in a position where the margin for error is shrinking. And this is where the hypothesis becomes more than a scientific curiosity. It becomes a mirror. Because if even one civilization existed before us and followed a similar trajectory, rising, transforming its environment, and then disappearing, then the silence we observe today is not just absence, it's outcome. Something ended their story. Whether it was internal failure, environmental collapse, or a combination of factors, the result was the same. No lasting structures, no clear records. Just a faint signal buried in layers of rock, waiting for someone else to question it. And now, that someone else is us. But here's the critical difference. We are not limited to guessing. We are aware of the risks. We understand climate systems, ecological balance, and the consequences of unchecked growth in ways no previous species, if one existed, may have understood. That awareness gives us something they may not have had: a choice. We can continue on a path that prioritizes short-term expansion, assuming that adaptation will always keep pace with change. Or we can recognize that intelligence is not just the ability to build and innovate, it's the ability to anticipate, to restrain, and to act before irreversible damage occurs. Because survival at this level is no longer automatic. It becomes a decision, and this is where the deeper meaning of the Silurian hypothesis begins to emerge. It's not really about proving that another civilization existed. It's about confronting the possibility that civilizations are inherently temporary unless they solve a very specific problem: how to sustain themselves without destabilizing the systems they depend on. That problem may be the true filter. Not the emergence of intelligence, but the ability to manage it responsibly. If that's the case, then the question, are we the first, becomes less important than another question: will we be the ones who last? Because the universe does not preserve stories out of sentiment. It preserves what can endure physical processes over time. Everything else fades. And right now, we are writing our own layer into Earth's history. A layer that future observers, if they exist, will study. They won't see our cities the way we do. They won't hear our voices or read our languages. They will see patterns, chemical traces, abrupt changes. They will reconstruct our existence the same way we are trying to reconstruct the past through fragments. And from those fragments, they will try to answer the same question we are asking now. Did this civilization understand what it was doing? Did it recognize the risks in time? Did it adapt, or did it collapse? Because in the end, that's what this entire investigation leads to. Not a hidden past filled with lost empires, but a deeper awareness of how fragile intelligence can be when it reaches a certain scale. We may never find definitive proof that something came before us, but we don't need to. The possibility alone is enough to change how we see everything. Because if civilizations can rise and vanish without a trace, then survival is not guaranteed. It is earned, and for the first time in Earth's history, we are in a position to decide which path we take. Not just for ourselves, but for whether anything we build will still matter millions of years from now.